Alright, so I'm going to work through your math boxes assignment. This is page 285. We've done some of them already, but we're going to look at box 2 today. And you're going to want scratch paper for box 2. There's a lot of work. I'm not sure you're going to have enough room. But I showed you in the video from yesterday's lesson that what you need to do here is take the Santana's amount of water, which is 4,263, divide that by 7. Then you're going to subtract the Merman's water, which is 3,955. But before you can do that, you also have to divide that by 7 because we want to know how much water they use per day. So that's going to give us liters. Okay? I'm going to do each of these steps. I'm going to help you get going if you couldn't do it. So starting with the Santana family, we have 4,263 divided by 7. And 7 can't go into the 4 here, so what we need to do is we need to think about it. What times 7 is 42, or as close as you can get. You can get that perfectly, okay? But if you weren't sure, you could probably start with 7 times 5 gets you pretty close to 42. But what I would have probably done, because again, this is why knowing your multiplication facts are so important. And there are plenty of ways to practice online. You can find where they will give you like online flashcards. Maybe that's something that you might want to consider. Is 7 times 6 I know is 42. Now I'm going to add my 2 zeros. Because 7 times 6 is 42, but 7 times 600 is 4,200. Now I can subtract. 3 minus 0 is 3, and 6 minus 0 is 6. 2 minus 2 is 0, 4 minus 4 is 0. So now the problem becomes 63 divided by 7. And we're thinking, what times 7 is 63? And again, if you know your multiplication facts, you know that 7 times 9 is 63. And I can subtract that. So I don't have to add any zeros there because I had just had 63, and 7 times 9 is 63. So your answer for how much the Santanas use is 609. So I'm going to take that over here and I'm going to write it above the blue so that I know that it's 609. And I'm going to use that and subtract whatever it is that the Mermans use. But as you can see, I don't have enough room to do the Mermans without doing that. So again, I'm going to delete that, and now I'm going to do the Mermans, which is 3,955 divided by 7. And now, this one's a little more challenging because 7 doesn't perfectly go into 39. You have to be thinking, what is the closest I can get? Now, if you think you know how to do this, you should pause me and then work through it on your own. But if you're not sure, watch what I do first and then try and finish the step on your own. Pause me as soon as you think you know what to do and try it. So, I would have gone with 5 because 7 times 5 is 35. And if I do any more, 7 times 6 is 42. I got to put in my zeros, and I subtract. 5 minus 5 is 5, or excuse me, 5 minus 0 is 5, 5 minus 0 is 5, 9 minus 5 is 4, and 3,000 minus 3,000 is 0. So now I'm thinking, what times 7 gets me close to 45? And if you did the work with me for the Santanas, you know that 7 times 5 is 35. So 7 times 6 is going to be more than that. 7 times 6 is 42. Add a 0, add a 0. Subtract. Again, every time that you think you know what to do, try and do that step without me. Pause me when you think you don't need me. So now we subtract. 5 minus 0 is 5. 5 minus 2 is 3. And 400 minus 400 is 0. Now the problem is 35 divided by 7. And we can think, what times 7 is 35? Okay, try that step. You should know that. You can even look up. We should know what times 7 is 35. It's 5. 7 times 5 is 35. 35 minus 35 is 0. So your answer for the Santanas is 565. So I'm bring that over here, 565. So now, again, I don't have enough room to do that right here, so I'm going to erase all of this work. Hopefully you got that. If you need it, rewind, rewatch it, because that's the beauty of having this online. Now, so now the problem becomes 609 subtract 565. And you can probably do that on your own and get the liters. So I want you to do that right now. Pause me and do that. 9 minus 5 is 4. Cross out the 6, make this a 5. This becomes 10. 10 minus 6, 4. 5 minus 5. So we end up with 44 liters. But we need to be able to change this to milliliters. And I showed you yesterday what you need to do with that 44 is take it and times it by 1,000, which actually isn't that bad because all you need to do is 44 times 1, which is 44, and add your 3 zeros. So the answer down here was 44,000 milliliters. Alright, here we go. Moving on to the last two boxes. We had done A and B, so we're going to look at C here. And I'm going to make them bigger because I know they're little numbers. So we're looking at C and D. And when you're looking at this, the whole numbers are fine, the 7 and the 4, that's fine. But what doesn't work is that we've got hundredths right here and tenths here, so we have to change this into hundredths. And essentially what you're doing is multiplying that fraction. We're at tenths, we want hundredths. What times 10 is 100? Well, 10, whatever you do here, you have to do on top. Same thing to the denominator and numerator. 10 times 10 is 100. 5 times 10 is 50. So this becomes 50 hundredths. And now you can add that. 7 plus 4 is 11. And 7 plus 50 is 57. And your hundredths will stay the same because when you add fractions or subtract them, the denominator won't change. Looking at letter D, if you haven't done it, maybe you should try it on your own. Again, the whole numbers are fine. It's this 9 tenths. We need to change 9 tenths into 100ths. So you look and you say, okay, I need hundredths. What times 10 is 100? 10. Whatever I do to the denominator, I have to do to the numerator. And 9 times 10 would be 90. So we're going to change this to 90 hundredths. 8 and 5 is 13. 90 plus 28. That one, I'm guessing most of you should probably do this and add it. You know your denominator is going to be 100. Okay? 0 and 8 is 8. 9 and 2 is 11. So I get 118 thirteenths. Now, if you were doing that, you guys know that I've told you, you don't necessarily need to reduce this and make it, because this is an improper fraction, 118 over 100, but you could. And then what you would have, if we did this in steps, is you'd have 13 and 100 hundredths, because I'm just taking 100 hundredths, and then I'd have 18 more hundredths, because 100 plus 18 is 118. What I can do in my next step is combine these. This is the same thing, 100 hundredths is the same as 1 whole. So 13 plus 1 is 14, and what's left over? 18 hundredths. So that could also be an answer for this. Instead of 13 and 118 hundredths, you could have 14 and 18 hundredths. All right, we got 2 more to do. This time we're subtracting fractions. And if you look at this first one, they try and mess you up here by flip-flopping these and not giving you what you need to subtract. Well, what you can do then is start from here and add your way to this. So here's what I think. I think, how much more do I need to get to 5? 3 plus 2. And what do I need to do to get to the 2/3? I need to add 2/3. So 5 minus 2 is 3. 2/3 minus 2/3 is no thirds. This one we actually have to do some subtracting on. So I'm going to set that up. I got 9, 5/12, and I want to subtract 2 and 7/12. And we can't just do that. The reason we can't just do that is because 5 can't take away 7. So when we've done this in the past, we know that This part is always going to stay the same in the next part, so I'm just going to write that. Minus 2 and 7/12. That's not going to change. What we have to change is this. We know that the denominator is still going to be 12ths, and one thing that we know is when we cross out this 9, it's going to become an 8. We're taking 1 away from it. So really, all we have to do is figure out the numerator, because the rest of it's super easy. We're taking 1 away from the 9, we're regrouping, we're going to change that into a fraction. We know we're going to have 12ths, but when we take that 1 away, because we know it's going to be in 12ths, it's 1 whole, and 1 whole and 12ths would be 12 12ths. The last thing to do is just to combine how many 12ths you have. We have 12 and 5 more, so that would be 12 and 5 is 17. Now it's an easy subtraction problem. It's just whole number minus whole number, fraction minus fraction. 8 minus 2 is 6. We know that our denominator is going to be 12ths. 17 minus 7 is 10. So you should have gotten 6 and 10 12ths. And those are your math boxes today. Thanks, guys.